Sometimes as we explore the world around us, we encounter features that are deeply mysterious and cause us to reflect on our place in human and geologic history. In this video, we will explore an undocumented wall in the desert Badlands that has very compelling and unusual features. Could this be the wall of an ancient city? Although I've been out into the desert Badlands 100 times or more, they continue to instill a sense of wonder in me, and I always find things I've not seen before. It's kind of like going on a treasure hunt. I'm looking for and finding clues to the ancient past.
What a beautiful day. Spring day, have some wildflowers out. Love hiking out in the desert. You know, my great uncle Cliff brought me out here. It's been over 40 years ago to show me this rock wall. And I'll tell you, I was sure impressed then. And I continue to be impressed. Let's take a look. I see it right over here. I'll never forget coming here 40 plus years ago with Cliff and seeing this rock wall. Boy, it sure amazed me and fascinated me. And in particular, I remember this opening through the wall here and wondering if it's some kind of an ancient passageway, that this could have been a wall that protected an ancient city. And one thing that's really pretty fun about this is almost nobody knows about this place. A small handful of people know about it. And those that have come out here, they look at this and they think of the obvious. This has to be the wall of an ancient city. And it sure appears that way, doesn't it? But in order to be confident with that, we need to use the scientific method and think through things and make observations and make a decision for ourselves. So let's get started with that.
The main wall is about 150 yards long, is up to 20 feet tall, and is typically about 2 feet thick.
Looking at this wall here, it's really interesting to see how it's put together, isn't it? And from here down, it certainly reminds me of the photos I see of Rockwall, Texas. I wish I could show you those photos, but they don't seem to be publicly available. They're all copyrighted. But boy, it's really interesting, isn't it? It turns out that there's more than one wall in this area, and I find this one particularly interesting. Let's take a look.
It appears that the wall is composed of carefully carved and placed stones. It's reminiscent of the famous rock walls of Machu Picchu in Peru.
Now, of course, being a geologist, the first thing that I start to think about is there any way that this could potentially be a natural phenomena? And my mind starts to go through other wall-like features that I've seen that are geologic in nature.
Hiking in the somewhat alien landscape along the Shoshone River not too far from Yellowstone National Park is a good place to see a type of natural wall that many are familiar with. This wall is a volcanic dike that formed as molten rock under extreme pressure fractured the earth, forcing its way to the surface. This particular one is associated with a giant stratovolcano that was active about 50 million years ago. It's much older than the Great Volcano of Yellowstone.
I've gone along this wall and looked at it carefully with my hand lens on a few places, and I can tell you it's not volcanic, so that's interesting. It's made of sandstone.
There is another type of natural wall we can compare it to, and a great place to see this type is along the spectacular Clark's Fork Canyon.
One of my very favorite rock walls right here. Just beautiful, nice smooth surface. It's bigger than you might think, as you'll see when we see some drone video. And in fact, when you're looking at the drone video, see if you can figure out how this formed. I'll tell you what, there is a clue on that mountain way back there behind me.
I never cease to be amazed at the beauty of our Earth and the variety of processes that occur to create such inspiring landscapes. Understanding these processes and the deep time involved helps us appreciate the landscapes we encounter in a much deeper, more meaningful way. What are your thoughts on the formation of these rock walls? Let's take a look at the nearby mountain that contains clues that I mentioned. Hopefully you noticed that the great rock formations have been dramatically deformed, creating a giant fold. All through this part of the fold, the rock layers are vertical or nearly so. We see some amazing walls along the front of this fold. Back at the red walls, we see evidence for a great fold that has been deeply eroded.
A whiteboard drawing to help us understand the formation of these majestic, beautiful walls we've been looking at. It's a cross-sectional view, so I have my little tree here growing on the ground. So this would be ground level across here, right? And then up to the mountain on the right with this big fold in the mountain. The dashed line is simply representing a rock layer or a formation of rock that has been eroded. Like here and here, it's been eroded away back down to here. I could draw many of these dashed lines because all of this has been eroded to the present configuration. Now to the formation of these walls. It's really rather simple. I've got this heavy dark line here. That represents an easily eroded shale. And of course, it used to go up and over, but it very quickly and easily erodes down to this level here. And then we have a layer of limestone, a relatively thin layer, that's very resistant to erosion. And then on this side of it, you have more easily eroded shale again. And you can have cycles, so you can have multiple walls stacked in like we saw. And as you work further out from the mountain, you come to these red rocks. It's called the Chugwater Formation, just so you know. And it's the same process. More easily eroded shale on each side of the wall, of each wall, standing in relief from this differential erosion. Now, the way to know that you have a geologic wall like this, the best key to know, is that all these layers of rock are vertical or nearly so on each side of the wall. Everything's standing vertical. When you see that and you see walls, you know this is how they formed.
Here is a fine example of this type of wall. It's a sandstone wall in Stonewall, Colorado. Returning to the rock wall, what do you notice as you examine the surrounding or nearby rock formations? There are a lot of things one could notice, but what I want to point out is that the layering seems to be nearly horizontal. This is opposite to the vertical rock wall. This configuration doesn't fit the red rock walls we just visited, which of course tells us that they formed in different ways. This is really getting intriguing. Let's look a little more closely at the wall by following it to the south. It seems to be thinning. As I walk it out, I clearly see that it is thinning dramatically. Here, the wall is only a couple of inches thick and ends right here. And what's going on the other end of the wall? What do you think of the small walls that seem to branch off the main wall? Looking back to the south again, you may have noticed evidence for other smaller walls scattered about. Let's take a closer look at this one. This wall is definitely thinner. It's only about 2 inches thick or so over towards the bottom, and at the top it's up to about 10 inches thick. The top of the wall is about 25 to 30 feet above the base of the hill. It seems to go right through this hill, doesn't it? Another example of a small wall that apparently goes right through this hill. How many walls do you see in the foreground here? I see 3. 1, 2, and 3. A closer look at the first one, the second one, and finally the third one. This one sure is thin, isn't it? Locally, some of the walls are wavy.
I've sure enjoyed hiking around out in this area looking for clues. Clues and make these observations and try to understand what is going on out here. What happened? Why is that great wall over there? And why do we have these smaller walls scattered about? And I thought a nice place to make a key point would be right back here at this small wall that we visited earlier. It goes up, up, up to the top of the hill, which is a total of about 30 feet. It doesn't look like it from this camera angle, but it's up there. It's about 10 inches, 8-10 inches thick up at the top. And it seemingly goes through the hill. So I think we would probably agree what we would observe if we took an excavator and started digging along the front of this wall to clear it out. Just dig along here and remove all the dirt, all along here. I think we'd see that wall go right on through, don't you? And it'd go down at least to my feet. I'm sure it would, because I see it right here at that level. So we have this wall that goes, or this thin wall, relatively thin wall that goes right through this hill. Now this gives us something fun to think about. Do you think this wall, this thin wall here, relatively thin and delicate wall, could stand on its own? If it were freestanding, do you think it could have ever stood on its own as if someone had built it there? Boy, this seems very unlikely, doesn't it? I think that it shows us, because it's so delicate and thin and so tall, that this material, this mudstone on each side of it, has always been there supporting it the whole time. And so that helps us to understand potential processes involved in the creation of this wall. The first time we visited this wall here, I didn't focus on many of the details, but I wanted to show you it's not very thick. It's 4 or 5 inches thick. And the bricks, or the stones, the small stones that make up the wall, aren't as big as you might have thought. Let me put my hand on them so you can see the scale. Well, here they are, this really nice clean sandstone, these small stones, or bricks if you want to think of them that way, set in here in this wall. They're quite small. They're certainly a lot smaller than the ones at Machu Picchu and smaller than the features we see in Rockwall, Texas, aren't they? But nevertheless, very interesting.
And if you look at the stonework more carefully, you notice some odd things. What I want to point out are contacts that terminate within an individual stone. Why doesn't this contact continue on across? There are several examples of this in this image.
Now that we've made a lot of observations together of this main rock wall and others surrounding it, and visited other types of walls, what are you starting to think about this area, this main wall? And what do you think the odds are that it's man-made, or that these are man-made out here? And if you don't think they're man-made, well, how could they possibly have formed naturally? That's the obvious question, isn't it? I think it's time for a whiteboard discussion, don't you? Let me turn here to a sketch I've done. Now this is a cross-sectional view, so I've got to do my tree here, don't I? I'll put it right over here. A nice tree right here. And these are the layers of rock, of course. Let me start up here. We'll have a mudstone layer, a layer of shale or mudstone. Then in the red dots here is a sandstone. I have blue lines here, which I'll come back to in a minute, and various other layers underneath. This will be a river channel with some water flowing in it. We have some happy alligators and hippos swimming around in this river, actually, at the time. So this is the basic scenario. The river defines kind of the water table at the time. So Usually the water table goes pretty close to the typical level of the water within the river, and it would go across the landscape if I were to draw a water table along here, meaning that anything below that point, this water table, would be saturated with water, including this sand. Now let me put some basic thicknesses here. Let's say this is about 30 feet of shale or mudstone, and we'll say 5 feet of sandstone here. But it's fully saturated, and that's why I've drawn these two blue lines representing water. So this sand is fully saturated, and it's only buried, in this case, 50 feet, so it hasn't had the opportunity to be cemented together, all these sand grains, because as burial occurs in time and you have mineral-rich waters, all these sand grains get cemented together quite tightly. So it's loose sand, essentially, filled with water. I think it's time for a fun thought experiment. Now, I want you to think about what this world would look like. What would happen to this world if I could convert this layer of sand here to water? We have 30 feet of mudstone on top. That's a lot of weight on a layer of water. I think there would be some major repercussions. One way you can kind of think about it is if you take a liter of Coke, you know, in one of those plastic liter bottles, and put it out there and drive your car over it. It'd take a pretty heavy car probably. You know what happens. It gets up on that bottle, and the container, that plastic container, cannot withstand the pressure, and it kaboom, explodes. I think something like that could happen in this situation, don't you? I think it'd be very unstable. A lot of you right now are thinking, well, Myron, this is a cool thought experiment, but isn't this rather wild to think about? What do you mean, a layer of water? How could that possibly happen? How do you convert sand to water? That's a heck of a question. But it turns out that it's a common phenomena that many of you will have experienced. Have you ever walked along a sandy beach, or maybe a bar of sand along a river that's got some water in it that's very stable? You can walk across it, leave a slight impression with your foot or something, but if you start tapping that sand with your foot, you know what happens. You start converting that firm sand to a non-Newtonian fluid. It fluidizes. It converts to quicksand. And that's how that can happen here. All you need is a big earthquake to really rattle things up, shake it up, and it turns this seemingly stable situation into very unstable, because this converts to a fluid.
To see a video of this process that occurred during the 2011 earthquake in Japan, click on the link I have provided in my video description.
Now, I talked a lot about this in another video I did, where I showed some giant features associated with fluidization of sand like this that I think would be helpful to watch. I'll put a link to it in my video here, in the video description. So continuing with this whole system, what happens? Well, think about it. This weight, this massive weight, far more than any vehicles that you could put on this, all this weight on this layer, it's got to escape. This fluidized sand, this slurry of sand and water, it has to go. And it breaks up through. I'll put a big break fracture in the earth here, where fluid is coming up out of this layer, up to the surface, and boiling out onto the surface. Some of them are fractures. Maybe I'll do another one over here. And it's not, rather than a fracture, it's more like a pipe, like a volcano. And the fluid comes up here and shoots up through there, through this conduit, building out on the surface, this sand, and creating this whole crazy situation. Now, these volcano-shaped ones, they've been documented in many earthquakes, as well as the fractured ones, but these occurred, are well documented in that great earthquake, the New Madrid earthquake of 1811. People witnessed these occurring, and they're referred to as sand boils. At least they're often referred to as sand boils. As far as what's preserved in the geologic rock record, usually it's the actual conduit, the pipe conduit here. Geologists call them clastic pipes, what you see in the rock record. And that's what I documented in that other video I mentioned, gigantic versions of these. And then in the fracture here, they're referred to as clastic dikes. And that, I think, fits what we're seeing in this wall, this mysterious wall we're looking at. Is this a clastic dike, or a series of them? I think it's important to look from above in a map view. We've been looking in a cross-sectional view. Let's look from above. Over here with these sand boils, they would be circular features, piles of sand that have built up as it's coming out with all this slurry. And you can have hundreds of these over very large areas. They're documented like that. And of course over on this side they're more fracture shaped, so I'll draw some fractures. You can have maybe a big one like this, some smaller ones adjacent to it, offsetting, or maybe branching off of a fracture like so, etc. Much like what we saw out in the field there with our wall. Now to our final sequence of events that occurred. You know, this all occurred about 50 million years ago, a long time ago. But deposition continued to occur, so these sand boils and the fractures and all that slurry, all that sand coming out onto the surface must have been quite the scene. Now deposition through time continued to occur. Let me erase my tree here. And now I'll just put layer upon layer upon layer of rock that built up on top, some 5,000 feet. And then about 15 million years ago, erosion started to occur and erode all these layers down, 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 all around, into here, cut this out, all through here, erosion through time. Rather predictable in a way, because these happen to be more resistant. These conduits that were feeding this material, they're good conduits for water, groundwater later, so they typically, or often anyway, are cemented better by the groundwaters. And they're harder. And plus you have mudstone around it, which is soft. So it erodes down here more quickly, leaving walls and or big cylindrical pipes like in my other video over here. And so let me draw this final surface here. So there we have it. We have on this side where there are fractures that occurred, we have these walls, big and small, short and long, and patterns like we see down here in map view, standing in relief above the ground, or at least at times standing in relief. And over here the same process, but they're pipe-shaped, these features. Wow, what an amazing series of events to create these fascinating and mysterious features that we enjoy so much as we go out exploring.
By the way, as far as I can tell, this wall is one of the best, if not the best example of a clastic dike in the world. There are some nice examples of clastic dikes in Badlands National Park, as shown here. When you think about it, the dikes form in quite a similar way to these amazing volcanic dikes in Utah. They both are fluids under tremendous pressure that inject into and fracture the earth as they rise to the surface. As far as the fracture patterns that look much like stacked stones, I will say two things. First, I'm not an expert on these types of fractures, and so I won't hypothesize as to the way they formed. And second, I've seen countless examples of natural fractures that have unusual patterns, and therefore I don't find these to be all that surprising, especially given the unusual way the rock was deposited.
What a beautiful view I have here looking across the Bighorn Basin. Gosh, I see the mountains about 80 miles away or so. And the storms are building up. Rain's heading my way here soon, it looks. So I've got to wrap this up. But isn't it amazing to think about the series of events that occurred to form this wall here? You know, this great earthquake that must have terrified all the early mammals out there, the early hippos. We had Eohippus, the small horses out running around. We had crocodiles in the rivers swimming about. And then this happened. And can you imagine if you'd have been right on top here where this great crack opened, fissure opened, and fluidized sand shot up to the surface and boiled out in a big wall like this? Boy, it'd be a bit exciting, wouldn't it? Which brings me to a point. I know many of you, or some of you anyway, are probably disappointed that this didn't end up being built by early civilization or something. And I like to think that it's equally amazing and fascinating to me in either scenario, whether it's man-made or made by nature. And I hope you've enjoyed watching this video. Thank you for watching.